So welcome back to my channel. In this video we'll discuss LeetCode 236, that is lowest common ancestor of two nodes. This is a very important problem. So first we'll discuss the problem statement. What the problem statement says. Here in this question you will be giving three parameters, that is first you will be given the root of the node and two other nodes, that is for which we have to find the lowest common ancestor. Let us say these are this and another is this. Okay, so the lowest common ancestor means that at the whenever we go up, the lowest ancestor, the lowest node for which we see a deflection point, that is in this tree if I say lowest common ancestor for this and this is this node, because these both are getting derived from this node and it is the lowest nearest to them. If I say tell me the lowest LCA, lowest common ancestor of this node and this node, then it is, we'll come back above. So I can see there is only one, that is this root node, which is deriving this and this node, right? Okay, so and what if I ask the LCA of this node and this node? So we can again see that root node is the LCA of this node. Okay, so clearly as we understand the problem statement what LCA is, so to find out the LCA of this node, we'll again check which node is deriving. Okay, for this. Okay, so what I find out, that root node is the LCA of these two. Okay, the root node is the LCA of these two nodes. What if I say that LCA of this node and this node? Okay, this is an important part. At edge case, this could be an edge case. Tell me LCA of this node and this node. So I can see that this node is deriving the other, so it is itself the LCA of this node and itself. Okay, every node is its LCA of itself. If I say LCA of this node and this node, so I can say this node is deriving this, so this becomes the LCA of this node and this node. Same if I ask LCA of this node and this node, it will be this, right? It will be this node. Okay, so now we move on, and first I'll write the code, then we'll understand line by line, and then I'll do a dry run of the code. Okay, so the question is saying the return type should be tree node type. Okay, we have to return the node which is the LCA of these two. Okay, so the return type is node. I'll write node. Let us name the function as solve, and it has three parameters as I told. The first is the root of the tree, and the other two are, let us say, P and Q, the two nodes for which I have to find the LCA. Okay, now a base case, that what if the root is null, then return null, because if there is no node, we can say that they cannot exist in LCA. Okay, now, and it is guaranteed in the question that P and Q lies in the node in the tree. Okay, these two nodes lie in the tree. Now if I come at position that if the current node is equal to P, or if it is equal to Q, in this case I will return this root, that I have come at the point where I have got any of the two nodes. Okay, now as we say in DFS, what we do? we break the larger problem into two. That is, for each node we check at its left and as well as at its right, and after that we conclude the problem. We write some statement with which we get the answer. So I'll name it as left, node left, that tell me the node from the left, does the answer lies in the left. I will call this function solve, return root dot left, and pass p and q. Similarly, I'll ask in the right, does the answer lies in right, solve root dot right. Okay, so now I'll tell this within an example. If I'm asking the LC of these two nodes, then for this node, if it will call root dot left, there is this is p node, this is q node. Okay, if I'll call root dot left, then we can see that there's no node in the left of this root which is either equal to p or q. So it will come down till here and it will hit this root equals to null, and it will return null. Okay, so we can see that if the p and q doesn't lie in any of the side, this will get null in its left. Okay, and in its right, it will get this any of the node which is the answer. Now we got the node from answer from left and right. Now what if I say p would be this and q would be this, then one answer I'll be getting from left and one answer I'll be getting from right. I'll write, and that will not be null. I'll write if left is not equal to null as well as right is also not equal to null. If this is the case, then return root. Okay, then return root. In this case, another. If this is not the case, then any one of it is null. Like what if left is not equals to null? Okay, if left is not equal to null, then return left. Okay, and if it is not hitting this condition, and also it is not hitting this condition, then must be the right is not equal to null. In that case, return right. Okay, so this is the code for LCA, the lowest common ancestor. Now we will do a dry run. So I have taken an example here. Here this is p and this is q, and this is the root. Okay, now I will go line by line. I call this solve function with this root and p and q. Okay, now it will check, is root equals to null? No, it is not. And does root is equal to p or q? No, it is not. Then do what? Then move to its left. I'll go left. Now this node will again call, and it will come over. It is not null. It is not equal. Even it is not equals to p and q. Then do what? Then go towards its left. It will come over here left. Okay, now it is here. Now this node will also call this function. Is it null? No, it is not. Is it equal to p or q? No, it is not. Then again go to its left. It has not, we are here. Okay, toward here. Now if this node has called this function, it is at null. Okay, then we hit this condition null, and this has got null from its left. Okay, now this node has completed this statement. Now this will move towards its right. Here it will call root. This will call root dot right. So it will hit this base case and get null from its what? It will get null from here. So since it has got left null from here, that means you can say now it has completed execution of this line. It will check, does left is not equal to null and does both not equal to null? No, both are null. Does left is not equal to null? No, left is null. Then return right. That means right, like null, return null. So this has got null from its left, this node. Okay, now this node has completed its left call. Now it will come towards its right call, that is this will come over here, right? Yes. Now this node will again call its left, it will come over here. Now for this node it will, now this node will call its left. Okay, now for coming this node, when this it calls root dot left, this p comes over here as a root. It will check, is it null? No, it is not null. Does root is equal to p or q? Yes, this node is equal to p, so return this root. Now return this root back. So this node has got p from its left, this node has got p from its left. Okay, this node has got p from its left. Now this node has completed its left execution. Now this node will call for its right. Okay, call for its right. When it goes towards its right, it will get null because it is not equals to p and q, we can see. So it will give null from its right, and this has this node will hit this condition, left is not null, so it will return p over here. I told it has got nothing from its right, so it will get null from its right, and again this node will hit this condition because right is null, because left is not null, so it will return left, that is this node will return this to above. Now this has got p from its right. Now this node, after executing this, it will check the conditions. Now this will hit this. Okay, both are not null, we can see. Left is not null, no, left is null, so it will return right. We have p in its right, so the root has got p from its left. Okay, q has this root has completed its right execution, that means this root has completed execution of this line. Now it will call root dot right. We will come over here at this node. Coming at this position, this node again will call root dot left. Okay, it will come over here. Now this node will call root dot left, but at its left it has null, so it will hit this base case, and this node will have null from its left. Now this node will call root dot right, pointer will come over here. Okay, now for this node it will check, is it null? No, but is it equal to p or q? We can see it is this is equal to q, this is equal to q, so this will get q. Okay, so this will return q above over here. Now this node has got null from its left, but at right it has q. Now this node has completed execution of these two lines. It will check the conditions. Does both not equal to null? No, one left is null. Okay, it will check, does left is not equal to null? No, left is null. Now return right. We have q in its right, so this node has got q from left. This node will call root dot right. We will come over here. For this node, it will again check these two conditions. Not satisfying, it will call root dot left. It has null from left as well as null from right, so it will not it will check the conditions and not satisfy above two conditions, so return right, that is null, return null above. Okay, for this node it has q at left and null at right, so this node will check conditions and it will say that left is not null, that is q, so this node will return q above. Now root has executed this line as well as this line. It will check the conditions. Does both not equal to null? Does left not null and right not null? Yes, in left we have p, in right we have q, so it will return root. So our answer is q. Okay, it will return q, and we can also verify that it is q is here and p is here and q is here, so we can trace it ourselves. Yes, this should be the answer, and this is what we got by doing a debugging or a dry run. Okay, I hope this question was clear very much. If any doubt, drop it in the comment box. Thank you.